as a Navy corpsman in Vietnam from 1967 to 68. After earning both a bachelor's degree in biochemistry and a PhD in physiology and pharmacology from the University of California, San Diego, he was appointed professor at SUNY at Buffalo and the Roswell Park Cancer Institute. In 1984, he moved to the National Institutes of Health campus, where he developed express sequence tags, or ESTs, a revolutionary technology for rapid gene discovery. In 1992, Dr. Venter founded the Institute of Genomic Research, a nonprofit research institute, where in 1995, he and his team decoded the genome of the first free-living organism, the bacterium Haemophilus influenzae, using his new whole genome shotgun technique. In 1998, Dr. Venter founded Celera Genomics to sequence the human genome using new tools and techniques he and his team developed. This research culminated with the February 2001 publication of the human genome in Science. He and his team at Celera also sequenced the fruit fly, mouse, and rat genomes. Dr. Venter and his team at JCVI continue to blaze new trails in genomics. They have sequenced and analyzed hundreds of genomes and have published numerous important papers covering such areas as environmental genomics, the first complete diploid human genome, and the groundbreaking advance in creating the first self-replicating bacterial cell constructed entirely with synthetic DNA. Dr. Venter is one of the most frequently cited scientists and the author of more than 280 research articles. He is also the recipient of numerous honorary degrees, public honors, scientific awards, including the 2008 United States National Medal of Science, the 2002 Gairdner Foundation International Award, the 2001 Paul Ehrlich and Ludwig Darmstädter Prize, and the King Faisal International Award for Science. Dr. Venter is a member of numerous prestigious scientific organizations, including the National Academy of Sciences, the American Academy of Arts and Sciences, National Academy of Medicine, and the American Society of Microbiology. And as of last night, he was recognized as one of the 100 most brilliant minds in business by Forbes Centennial. Please join me in welcoming Dr. Venter. So, systems biology, synthetic biology, computational biology, epigenetics, chromatin biology, all fields that were at minimum catalyzed by the Human Genome Project, but probably most of them were really born around the findings of the Human Genome Project. What in the last 15 to 20 years, as these fields have developed, has excited you and surprised you as a result of the Human Genome Project?
So I think the biggest surprise, other than technology development, was almost nothing happened. And it's because we need technology to go to the next stage. And I had sort of set a threshold of when we would start up again. Our first genome took 9 months to do and cost $100 million. So they weren't very replicable events. So we waited till it got down below $2,000 a genome, which happened about 3.5 years ago. So we started human longevity to try and understand the genome. Basically, standard genetic tools are dead. And the only way, in my view, to understand the genome is to have tens of thousands, potentially millions of them, but all with corresponding clinical and phenotype data. Because we all differ about 3% from each other, and we're not going to understand that comparing 2 or 10 genomes. And that's why so little has happened. While it was a big deal to learn how many genes we had and the overall structure of the genome from the first ones, I think the reason there's been no progress, or very little progress, is because it's a data set that's been too hard for people to interpret with standard experimental methods. So we set out to start sequencing. We sequence a genome now roughly every 12 minutes, 24 hours a day, 7 days a week. And the price is coming down. It's well below $1,000 now. We hope within started working with pharmaceutical companies doing their clinical trials in exchange, offering discount rates in exchange for all their phenotype and clinical data. But it turns out the amount of data you get with clinical trials is very limited. So we decided to start our own phenotyping center, which we now call the Health Nucleus, where we set up extensive MRIs, CT scanners, a wide range of things that we can go into if you want to.
I think I got a pamphlet.
Okay, good. And we just brought in healthy people, thinking we would develop a healthy human phenotype and at least have any measure we could take back to the human genome with machine learning to sort out the links between the two. And to our surprise, almost from day one, most of the healthy people turned out not to be so healthy. Roughly about 40% of them have something significant. And so that kind of changed our paradigm a little bit because it switched much earlier into preventative medicine and early discovery than we thought. We thought we'd have to do a whole lot more work on the genome first. But it's really starting to pay off. And the new tools, the new MRIs are such fantastic machines, and they're improving every year. So the new Siemens machine takes about 45 minutes to go through. We get a comprehensive analysis of your brain structure. It does volumetric analysis of 20 brain regions and can do a better analysis than any neuropathologist, just using an algorithm. And using that data and genome data, we can predict whether or not you're going to get Alzheimer's ever. Or we have a scale of what your likelihood in the next 3 years, the next 10 years, the next 20 years is. And it's turning out to be pretty accurate from that. We also see, because we don't use any contrast media, because one of the very great developments that happened at UCSD is just looking at water molecule differences in tissues. So blood vessels obviously contain a lot more water in motion than the surrounding tissues. So we get these beautiful pictures of the brain vasculature. And if there's occlusions, they show up. If there's aneurysms, they show up. Turns out 1% of the population has a brain aneurysm. They're usually diagnosed when they burst and you die, so it's really a lousy diagnostic method. You don't get a chance to do it again. And now they're treatable as an outpatient with interventional radiology, just putting a coil in. So what used to be a surprise death from a lethal disorder, 1% is a pretty big number when you look at the population. 1 in 50 of the population have aneurysms somewhere in their body. So we see a lot of aortic aneurysms, we see expanded aortas. 5 people have had now surgery because they had greatly distended aortas that were about to pop. So we work down the system so we can see your entire vascular tree. We can see if you have cancer. And roughly 2.5% of the people that we see over the age of 50 have a major tumor that would kill them eventually if they didn't know about it, and none of them knew about it. And so
Sounds about right.
This is with the new radiology techniques where the tumors essentially light up like bright lights because tumors have slightly larger nuclei, so they have more water, but the water is less mobile, so it gives off a very bright signal. For example, prostate cancer, there's 2 types of prostate cancer. There's the kind you eventually die with, and that's the kind you die from.
Right.
The MRI only picks up high-grade prostate cancer, the kind that you die from.
High grade being the fast growing.
That's the fast-growing lethal one. And our radiologist team using this new technique with the MRI, 15 minutes in the MRI, they can diagnose it and even grade the level of the tumor. And they've been 100% accurate with it. Thus far, half the people that are being diagnosed with prostate cancer have normal PSA and no symptoms whatsoever. So they would have never sought out going to a urologist to get treated or even checked out. If these metastasize by bursting through the capsule, the 5-year survival rate is about 28%. Thus far, we've all caught them before they metastasize, but I had the experience with my own clinic of while testing the new MRI machine, my friendly radiologist who works for me told me that I had a high-grade prostate cancer, which was really a surprise because I had elevated PSAs for 20 years and I had biopsies and was told I was cancer-free.
Well, anything can cause elevated PSA, right? Like, PSA is like a false positive rate of 75%.
Yeah, it's a worthless test until after you've had your prostate removed, and then it's a very valuable test because your level should be 0. And if you start to see them coming up, it means you have a metastases going someplace.
Right.
So I had my own life saved by the system, and they said if I had waited 6 months, it would have metastasized. So timing is everything with these. But every cancer that we've diagnosed, they've all 100% been treated, and they're all cancer-free now.
Amazing.
It's because we're detecting them early.
Right.
In contrast, we have a program sequencing tumors from people who already have cancer. And for example, we're dealing with 4 women in their 30s that have stage 4 colon cancer. That doesn't fit into anybody's screening paradigm of getting a colonoscopy when you're 50.
Right.
And so most people are diagnosed with cancer because they have some kind of symptom, usually caused by tumor metastases going to the bone or some other tissue. And so you get diagnosed quite often too late.
Right.
So this early detection is really quite something. I was dealing with, because we're working with Siemens, I was invited to talk to the CEO and the entire board, and I told them that the number of employees they have 10,000 employees with a cancer that they don't know about yet, and that we're using their technology to find these, and that maybe they should start doing that.
Yeah.
So with cancer, it's really interesting because those are immediate discoveries that lead to immediate treatment, that lead to life-saving conditions.
Yes.
On the cardiovascular side, the new MRI actually makes a wonderful movie of your heart. You can actually, we show people afterwards, you can see the blood flow through the heart, you can see all the valves, all the ventricles, and while you're in the MRI, the algorithm measures everything about your heart. By the time you get out of the MRI, 15 minutes later, the report is complete. So it's really changing in that regard. And then we measure metabolic state with the MRI. So we can measure the amount of organ fat that you have, and it's one of the most important parameters, and there's usually not a simple way for people to get that measured.
Yeah.
So normal liver fat is 4% or less. We've had probably 25% of people going through have a highly elevated liver fat. The highest is 38% thus far. That's somebody likely to need a liver transplant. These people are all asymptomatic. So it's this disease called NASH, so it's not alcohol related, it's non-alcohol related, and published paper showing an association with changes in the microbiome that may give some hints to that. But if you don't have it measured, you never know you have it until you have frank liver disease. And so we compare your visceral fat to your peripheral fat. And your visceral fat is far more important for your health and longevity than your peripheral fat. We also measure using metabolomics. We can measure your insulin sensitivity and detect pre-diabetes. So there's a show on HBO coming up again, I think, at next Sunday, where the young reporter thought she was perfectly healthy, went through the whole health nucleus, and because she was sure she was healthy, she wanted all her results live on camera. Turns out it was a mistake, but she had changes in insulin sensitivity that showed she was going to develop diabetes. She had a substantially increased liver fat, and she had an unusual for diabetes fat distribution, impaired distribution, and some other blood elevated factors. So instead of being healthy, she's at a point in her early 30s where she can choose one of two paths. If she continues down the path she's on, she'll develop diabetes. That always turns into cardiovascular complications. If you have cardiovascular complications, you will get early dementia. Whether it's Alzheimer's or not, it's just cardiovascular dementia. Or she can radically control her diet, prevent diabetes in the first place, and prevent this whole cascade of events going on. With the heart, aside from the MRI, we do 4D echo, we do cardiac CT scans. We're starting to see elevated cardiac CTs in younger and younger women. We have a woman in her 40s, not obese, no family history of heart disease, 4 major coronary arteries, had incredibly high calcium scores. That puts her at a 99th percentile for having a major cardiac event in the next decade. And it turns out she also